How do irreversible processes impact entropy in mechanical systems? Imagine a machine running smoothly, then suddenly encountering a process that can't be undone. That moment marks the beginning of entropy increasing in the system. When a process is irreversible, it means energy is lost or spread out in a way that can't be reversed without extra work. These processes are everywhere in mechanical systems. Think about friction in gears, heat transfer across a temperature difference, or fluids mixing. Each of these creates more disorder, or what we call entropy. Entropy is a way to measure how spread out or disorganized energy becomes in a system. In ideal situations, processes are reversible, and entropy stays the same. But in real life, most processes are irreversible, and entropy always goes up. The second law of thermodynamics tells us that in an isolated system, total entropy can never decrease. It either stays constant if the process is perfectly reversible or increases when it is not. Take friction, for example. When two surfaces rub against each other, some mechanical energy turns into heat. That heat disperses randomly and can't be turned back into useful work easily. This is a perfect example of how entropy increases because energy is lost to the surroundings in a less organized form. Similarly, when gases expand without restraint, the energy spreads out, increasing entropy. Every irreversible process adds to the total entropy of the system. This means more energy becomes unavailable for doing work. For instance, when a machine experiences turbulence or heat leaks, the energy that could have been used to generate motion or power is now dispersed. This loss of useful energy is directly related to the rise in entropy. Because of this increase, real mechanical systems are less efficient than ideal ones. Engineers need to account for entropy production when designing engines, turbines, and compressors. Reducing friction or improving heat exchange can help lower entropy generation, making systems more efficient. You can think of entropy as a kind of invisible fluid that flows into the system during irreversible processes. It's created, not lost, and it accumulates, making the system more disorganized. This concept helps us understand why energy degrades over time in mechanical systems. In practical terms, understanding how irreversible processes impact entropy helps engineers improve system performance. For example, designing better bearings to reduce friction or optimizing heat exchangers to minimize temperature differences can cut down on entropy production. This means less energy wasted and more reliable, efficient machinery. So, in summary, whenever an irreversible process occurs in a mechanical system, it causes entropy to increase. This increase signals energy loss and a reduction in the system's ability to do useful work. Recognizing and managing these effects is key to creating better, more efficient machines.